Good Wednesday morning, students. Hope you guys are up and at 'em, alive, and ready to do some math today. Middle of the week, so hang in there. Just 2 more days after today, and the week is over. And tomorrow, tomorrow I will not be teaching. Tomorrow you're going to work on the review sheet the entire hour. And Friday will be your test. So today's the last day of notes for the week, and then Friday is the day of reckoning. We'll see how you guys do. Okay, test on Friday. You owe me homework. I gave you 5 homework problems last night. So please turn those in at this time. And I told a lot of you young ladies, all incompletes have got to be turned in by Friday. So I went over that very thoroughly yesterday, and I hope that you're taking care of that. No activity today. We're going to jump right into the lesson because A, it's a Wednesday, and B, I want you to be able to work on the review sheet in class some today also, okay? Some of you have expressed thankfulness to me for doing this class. One of you students told me that yesterday also via an email. I want to say thanks for that. Thanks for taking time to say that. And it's my privilege to teach you guys, and I hope that we have a really good semester. Okay? All right, let's move because I want you to have time to work on the review sheet at the end of the hour today. So here we go. We're looking at part 2 today of lesson 5-6. Okay, so contain your excitement. Perpendicular bisector theorem. Perpendicular bisector theorem, lesson 5-6, part 2, and today's date is the 23rd. Now, very quickly, go ahead and copy that down. Again, I'm going to go fast, excuse me, sorry, and you need to pause the video if you need to. Okay, let's review what we looked at yesterday. You do not need to write this down unless you want to. Just sit back and relax. We studied the angle bisector theorem yesterday, and what we said yesterday is if we had an angle like this, and then we had a ray come out of it and bisect it like this, and of course if that line bisects the angle, that means this angle here is congruent to this angle here. So if we have an angle in which we have a bisector and there's a point that lies on that angle, what we talked about is this distance from there, of course the perpendicular line, will equal this distance here as long as that's a perpendicular line. So that's what we looked at yesterday. Okay, now don't confuse that with today's notes. And by the way, don't forget what else we talked about yesterday. Please, students, we talked about if we have a line and a point, and I said, what's the distance from that point to that line? And I said we could draw tons of lines from that point to that line. And I said anytime you're asked in geometry to find the distance from a point to a line, it is always the what line? Do you remember, class, from yesterday? It's always the perpendicular line. That's the distance they're talking about. Okay, that's a quick review from yesterday. I hope that helps a little bit. Now let's get into today's notes. This is what we're looking at today, so please copy this down. We are looking at the perpendicular bisector theorem, and it states if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Now, as always, I want to give you students a picture of what we're talking about. And so here we go. Let's say that I have a segment like that. And then let's say that I have a line that comes through and is a perpendicular bisector. Okay, so watch carefully. Here's a segment right here. Okay, and then I have a perpendicular bisector. Mr. Earhart, I forget what a perpendicular bisector is. Well, it's a line that's obviously perpendicular, so we have a right angle, and it bisects the segment. That's what this red line is doing. It is bisecting this segment, or in other words, cutting it in half. So if it's cutting it in half, then I can state that this segment right here is congruent to this segment over here. Do you see that? So I can put a slash here and a slash here. Okay, now we're not done yet. We're not done. That's not everything this theorem is saying. This theorem is saying if I have a segment and then a perpendicular bisector of that segment, now watch, it's saying if I have a point on this perpendicular segment like this, we'll call this point A, then the distance from this point to the end point, that line right there, do you see it? We're going to put a B here. We're going to call it AB. That distance is the same as this distance here. So I'm going to put 2 slashes here and 2 slashes here. That's what this theorem is saying. So again, for the 100th time, let me go over this. If you have a segment BC, and then you have a, let's go ahead and put a letter here so we can call this line AE, I guess. If I have a segment BC, and then I have a line AE that is a perpendicular bisector, in other words, it's perpendicular to BC and it cuts BC in half. If that happens, then this distance right here is going to be equal to this distance here. That's all that it's saying. And sometimes a picture, as the saying goes, is worth a million. What is that saying? A picture is worth a million words. So hopefully this picture will help you a little bit. That's what the theorem is stating. Okay. So with that in mind, let me jump on ahead here and see what else we got. And oh, my hooligans just got home. I thought they were at Chick-fil-A. Okay, I'm going to pause this video and we will pick it up here in just a minute. Okay, students, I am back. I've got some bad news for you, and if I was there, I'm sure you would want to throw objects at me, but we are going to do our first theorem proof, and you will have this on your test. Now that can motivate you to, really get upset or really listen well, and I hope that you'll listen well. On the test on Friday, I'm going to have this theorem written out for you, and I will say this: proof Theorem 5.4. That's all I'm going to say, and you are totally on your own. However, I'm going to do it for you now in class so you can memorize it and hopefully do well on the test with this. Okay, so again, on the test I'm going to say prove Theorem 5.4. I'm going to do it for you now, so here we go. Okay, whenever you are asked to prove a theorem, the first thing you do is you draw the diagram. So we have, it states, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So here's what you would do. The first thing you would want to do on your test on Friday is you would draw a segment like this, and then you would draw a perpendicular bisector. So go ahead and do that now, and you would draw a perpendicular bisegment like this. Okay, now let's go ahead and quickly, I would encourage you on the test, I would give some names to these lines. So let's call this right here point A, and let's call this over here point B. And look, it says if a point is on the perpendicular bisector. Do you see that? So we've got to have a point up here. So we'll put a point about right there and we'll call that C. And it's always good to give intersection points names, so we'll call this point E. You can use whatever letters you want in the test. You can memorize mine and use mine. That's totally fine. I don't care. I have no problem with that. That's your decision. Now notice what else the theorem states. If a point, there's our point, is on the perpendicular bisector, here's our perpendicular bisector. In fact, go ahead and put a right angle right here, and go ahead and put a mark here and a mark here, because we know AE is congruent to EB. So if a point is on the perpendicular bisector, then this point C, is equidistant from the endpoints. So what that means is this segment right here, AC, is going to be congruent to this segment here, BC. And that's what we're going to try to prove. That's what we're going to prove. So step one on the test, when I say prove Theorem 5.4, the first thing you do is you draw your diagram like this. Okay? All right, here's the next thing that you do, so please watch carefully. The next thing that you do is you want to write your given and your proof, so please let me help you with that. I'm going to go over here and use my eraser. Here we go. I have this typed already. Did you know that your given is always your if part? Maybe you didn't learn that last semester. The if part, I'm going to underline it, is your given. So there you go. If a point is on the perpendicular bisector of a segment. So I stated my given, EC. I'm going to go ahead and put my symbol. So do that, please. There's your line symbol. If line EC is a perpendicular bisector of segment AB. So there it is. That's your given. It's your if part. perpendicular bisector of a segment. The then part, I don't know if you guys knew this or not, hopefully you did, the then part is what you're proving. Did you know that? So the then part is what you're proving. So you're proving that this point, point C right here, that point, is equidistant from the endpoints of the segment. So what does that mean? Well, that means you're proving, see if this makes sense, you're proving that segment AC is congruent to segment CB. You're trying to prove this segment right here, AC, is congruent to CB. That's what you're proving. Okay? Now again, I hope you get this because you're getting it and you understand it. But if not, you can memorize this. You really can. It is not a long proof. It is a short proof. You can do this. So you first draw your diagram like we did here. That's the first thing you do. And then you write your given and your proof part. Okay, very good. Let's continue on. Now we would like to do what we call laying a plan of attack. Okay, we have got to come up with a plan of attack. So I am trying to prove that AC is congruent to CB. And I think I've got it. Let's call this triangle number 1 and triangle number 2. Here's my plan of attack. If I can prove that triangle number 1 is congruent to triangle number 2, then as soon as I prove that, remember when two triangles are congruent, their corresponding parts are congruent? So if I can somehow prove that triangle 1 is congruent to triangle 2, then I can state that AC is congruent to CB. That's a pretty good plan of attack. Now I think I can see how to do this. Remember how we proved that triangles are congruent? We can either use what? Side, 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 angle, angle, or angle, angle, side. Well, can you pause for a second and think of which one we'd want to use? I think I've got it. It's pretty obvious. Look, I've got a side here congruent to a side here. I've got an angle 90 degrees congruent. So I have a triangle like this and a triangle like this. I've got this side congruent to this side. I've got this angle congruent to this angle. And don't they share this side right here? You see how they share this side? Hey, I've got side, angle, side. Side, angle, side. Now all of this brainstorming that I just did, I'm about ready to erase. So write this down, okay? Do you see how I brainstormed? I said to myself, okay, self, if I want to prove that AC is congruent to CB, then I better prove that this triangle right here is congruent to this triangle here. And once you prove that, you can then state that AC is congruent to CB. So how can I prove these two triangles are congruent? Well, side, angle, side. Side, angle, side. So that's going to be my plan of attack, okay? So with that in mind, now all this is going to disappear in a second, but that's got to be my goal right there. Okay, so let's review. First of all, you draw your diagram. Secondly, you write your given, and then you write your proof, and then you come up with a plan of attack. Okay, all right, so here we go. We've done all of that, so let's start in with our statements and our reasons, okay? Here we go. Well, I've told you you're welcome to put a line there and then put the word given. You don't have to write that out, okay? Very good. Now don't forget what our goal is. Somehow we've got to state that this side is congruent to this side is congruent to this side, and these angles are congruent. So here we go. I'm going to have to write really small here. So the first thing I'm going to state is that angles A, E, C, and BEC. Now look at the diagram. That's this angle here and this angle here. Okay. I'm going to state that those two angles are not congruent, but that they are right angles. And I can also state that AE is congruent to EB. Now, students, what reason can I give? How can I state that? Well, it would be definition of a perpendicular bisector. I mean, the definition of a perpendicular bisector is it cuts the segment in half, thus this segment is congruent to this segment here, and it also is perpendicular, thus we have right angles. All right, Now let's continue on. By the way, I'm going to circle in green the things that we need to state to use side angle side. We need to state somewhere in our proof that this side here is congruent to this side here. And we just did that right here, so I'm going to circle that, okay? All right, let's continue on. Now, let me get a black ink here. Okay, now number 3. Can I not state that angle AEC is congruent to angle BEC? Mr. Harold, how can you state that? Well, you should have learned this last semester. There's a theorem or postulate or something I know in geometry that states that all right angles are congruent. There we go. All right angles are congruent. So that's something else I had to state. I had to state somewhere that that angle was congruent to that angle. So I've done that. All right. Now I might have to pause the video. I'm gonna have to get out my eraser and erase all of this and continue. I'm running out of room, so understand that. But so far I'm looking pretty good. I'm gonna go ahead and squeeze one more thing in here. I really am. Look at number 4. You know what we're gonna put, don't you? We've stated, let me get out my green marker here. We've stated this is congruent to this. We've stated this angle is congruent to this angle. The only thing left is to state EC is congruent to EC, right? I mean, that's what we have to do here. So let's go ahead and state that EC is congruent to EC. Remember the reason for that? It's called the reflexive property. The reflexive property. Okay? There we go. And now you've stated the 3 things you needed to state. There they are. So now you're ready to state that this triangle here is congruent to this triangle here by what reason? Remember? Side angle side. So I'm going to have to go ahead and erase this. And if you got to pause the video or whatever, that's fine. But I'm going to have to slide this over. Get rid of that. Get rid of that. And a little bit of the word statement there, but you guys know what was there. Okay, so step 5, I'm now ready to state what? Triangle ACE is congruent to triangle BCE. And what's the reason? Well, we just said it, remember? Side angle side. And now number 6. Now you can find, here's what you're trying to prove. All that hard work to prove that. And now you can state that AC is congruent to CB. Remember why you can state that? You're welcome to use CPCTC, or you can just simply say, if you don't like that, you can say corresponding parts are what? Congruent. And that's good enough. To me, this is a really easy proof to start off with. And I think that you'll really be able to handle that pretty well on the test on Friday. Okay, so watch again if you need to. But on the test, let me go back a couple slides here. On the test, I'm simply going to say to you, prove this. And you're going to have to prove it, okay? All right, let's take a look at a problem real quick here in your notes. And this is the only one we're going to do, and I'm done for the day. This is it, all right? Okay, take a look at what we have here, please. Watch this carefully. Write this in your notes if you need to. In fact, I would encourage you to copy this in your notes. Notice they're stating that we have this segment here, EH, has a length of H. And they're also saying that HG has a length of H. Do you see that okay? And then notice we have a right angle here. So what that's telling you is this. This line right here is a perpendicular bisector. Okay? This line right here, get rid of this ink here. This line right here, FH, is a perpendicular bisector of EG. And anytime you have segment, we'll call it segment EG, anytime you have segment EG being bisected by a perpendicular line, then remember this segment here is congruent to this segment here. We just proved that. So I'm asking you to find the length of VF. Well, think about that. We know that 2x plus 5 has to equal x plus 10. So we subtract x from both sides, put a negative x there and a negative x there, and we're left with x plus 5 equals 10. Now let's subtract 5 from both sides, and you're left with x equals 5. Now, it's not your answer. I didn't ask you to find x. I asked you to find the length of VF. And we know that EF equals 2x plus 5. So where the x is, we are going to substitute a 5, and you will get out 15 for the answer. So EF equals 15. That's the only problem we're going to do today. I now want you to do this. I want you to get out the handout that Mr. Harmon gave you, okay? And on that handout, you are going to see some theorems and postulates and corollaries that you have to have memorized, all right? And so with that in mind, these things on the test, I'm going to try to cut and paste this. Hold on one second. Okay, I'm back, students. Thanks for your patience there on that. Okay, this is the handout you should have from Mr. Harmon, and you are going to have to know all of this for your test. Now, please relax. I'm not going to ask you to quote these or to fill them out verbatim. Like, I'm not going to say to you congruent triangles and you have to write this whole definition. I'm going to do fill in the blank. I've done this for years for my geometry classes, and I leave out main words. I don't leave out these and ands and thes, but main words. So, for example, I might, let me get this here. Give me 1 second. I might have blanks here. Definition of congruent triangles. Two triangles that have 3, and I might have blanks right here. Corresponding angles congruent to 3 corresponding angles. That makes sense. And then 3 corresponding sides congruent to 3 corresponding. I might put blanks there. Okay, postulate 12. SSS postulate. And by the way, on the test, I leave these words right here. I give it to you just like this. Now that makes it pretty easy, because as soon as you see the SSS postulate, you know it means side, side, side. So it's really pretty simple. On this here, I might have these blanks. If blank blank of one triangle are congruent to blank blank of another triangle, then the two triangles are blank. Okay, so all you have to do is be familiar with these. It's all fill in the blank, okay? And then notice, and of course you're probably not too thrilled about this, but notice I put at the bottom of your review sheet here, this, be able to prove theorem 5.4. We just talked, wow, it's a really good circle, isn't it? Be able to prove this theorem, okay? It's the one we did in class today. Memorize it, know how to do that, okay? And so all of these are fair game. They're all going to be fill in the blanks. All right, and then do these problems here. Now there's going to be a video. In fact, I'm going to go ahead and tell you what it's called. Now I've got to think for a second. If you need to look it up at home, it's going to be like all of them start off with Berean Academy Geometry. Okay, and let's call this one. Let's see. Let's call it Berean Academy Test Review. Let's call it Test Review. So I'll make sure I name it that, and if you need help during your review sheet and you want to watch the video, all the problems will be worked out on there. And that's it. It'll be a tough test. You're going to have to study to do well. You might get A's, you might not, but I know everyone can pass for sure if you'll work really hard and do a good job. Okay, get started on your review sheet at this time. Make sure you've turned your homework in from last night, and all day tomorrow, or all class period tomorrow, you'll be working on your review sheet.